Welcome back to class, guys. We're going to be covering 3.3-3 and 3-4. So we're going to talk about rotations, and we're going to be talking about combination of our composition of transformations. So to have a rotation, you need to have a fixed point that starts us off. Let's look at the book real quick. Most of this will just be talking about the book, and then we'll look at some examples. Okay, so center of rotation is going to be a fixed point where you're going to rotate the pre-image to the image, okay? And it's going to rotate by certain degrees, a certain angle, which is going to be the angle of rotation. So clockwise is going to be to the right, and counterclockwise is going to be to the left. Positive is going to always be counterclockwise, okay? So, for example, this shows how to do it. So if you have a point, you use that to reflect each of your points from the image, okay? So you take that and then take it to make your other image, doing the exact same steps. Okay, apologies if they're not colored. I think this is alright. Okay, so the key concept. So rotations around the coordinate plane. When you rotate 90 degrees, the y and the x are going to switch, and the y is going to become negative. Okay, so that's 90 degrees counterclockwise around. So just know that the x and y switch position, and the y becomes negative. Okay, when you do 180, this is a rotation around the origin. Okay, so 180 degrees is rotation around the origin. And then 270 or 90 degrees clockwise will switch x and y, and x will then become negative. Okay, so you switch positions and the x becomes negative. Kind of like this example here. So if you're confused, look at the example, look where the numbers go and what happens to them. So they ask us this triangle and its image after 90 degrees reflection. So that means we flipped it. We change x and y and make the y negative. So you flip them, and then the y becomes negative. So you just do that with each part. Okay, 180 degrees, you're going to make each thing. So 180 degrees, you're going to then see what kind of vector we're going to get. So they say first rotate it around the origin and then move it and then translate it, okay? So if you have something where you have a different point, you first use the origin and then use the vector of that position, okay? So they have so they translate the position. Notice they translate first, then they reflect it, okay? And that's gonna be, so first they translate, then they reflect, and they translate it back. And why do they do both of these translations with this flipped right here? Is because this first one is to get it centered. The second one is to actually get it, second reflection, the second movement is to make sure it's same distance from the point given. Okay, so we'll have some practice problems like this. I don't think we will focus too heavily on rotations around a point, but just know that if you do have something like that, it'll be guided through, you'll have one guided problem in Delta Math and extra practice after that, okay? So that's rotation. So the easiest rotations, again, the one that I want you to center on is this key concepts right here, okay? So the key concepts is what you should be focused on. And this key concept right here. The practice of it, the practical implications of it, just know how, be able to read it. Okay, so read what they're telling you to do and what you need to do with that. Okay. Compositions of transformations. Okay, so like a glide reflection is going to be a translation with a reflection in a line. Okay, so right, you translate it and then you flipped it over. So in this case, you went W, flipped, flipped. Okay, so there's reflections along the line that's parallel to the translation. So in this case, if you first, so it's image here and it's reflection of the y-axis. So what they do is they first do the translation. So they translate it this amount of units, 0 to x and 4 to the y. And then once you get the new place, so they translate it. Once you get the new place here, then you flip it. And flipping it, reflecting on the y-axis is going to make the x's negative. So each of the x's is going to become a negative value. Okay, composition of isometrics. Composition of two or more isometries is an isometry. What's that mean? So an isometry is the word we need to get. It's basically, let's see if they've actually translated. Okay, in this case, it would be if you have so isometries are reflections, translations, rotations. That becomes one single, basically a composition of transformations is in itself one transformation. Okay, so this example, these 2 points of this line, reflect on the x-axis, rotate. So if you reflect and then rotate, it actually you would be able to find the single property to go from our original to our newest. Okay, reflections in parallel lines. The composition of 2 reflections in parallel lines can be described as a translation vector that is perpendicular to the 2 lines. So right, if you reflect it twice, you're going to have just a translation across. If you reflect it across 2 parallel lines, okay, it's going to be twice the distance of the parallel lines. That kind of makes sense because okay, basically shift. If you reflect it over one, then reflect it over the next, the distance between the first and last is going to be 2 distances, which is the distance between the 2 parallel lines. Okay, reflection of intersecting lines. A composition of 2 reflections in intersecting lines can be described by the rotation, so about the intersection, that twice the angle. Okay, so if you reflect it twice, it could be seen as one main reflection. Okay, so this is actually just one reflection that's double the angle. Okay, there's more practice. Just know that this theorem basically saying that if you're reflecting it across 2 intersecting, you have to reflect it over one. Reflect it and then reflect it, which is just going to be a major rotation. So the combination of reflections is going to be like a translation, or it's going to be like a rotation. Okay, I'll see you guys shortly in class. If you have any questions, come prepared to discuss in the class. We will have homework on Delta Math. See you then. Okay, bye guys.